In this video, we are going to look at the metric system, sometimes called the SI system. Most common things we're going to be using here are length, and that would be the base unit would be meters. A kindergartner, little over 3 feet, is about 1 meter. Masses in grams, there's 454 grams in a pound, so a gram is a real small amount, like about a pinch of salt. Notice we have time and temperature and something for amount of a substance. Volume in liters, as far as a liter is a little bigger than a quart, and then density is grams per milliliter or other mass over volume units. Here's some conversions between metric and English systems, which you might have done during dimensional analysis. We are not going to concern ourselves with that here. We're going to look at metric conversions and using a chart and understanding and how to do that. So if I had a meter, what would happen is I don't have a prefix in front of it. It's 10 to the 0, it's just 1 meter. If I broke that up into 10 pieces, I would have 10 decimeters. If I broke that meter up into 100 pieces, I'd have 100 centimeters. If I broke that meter into 1,000 pieces, I would have 1,000 millimeters. If I broke it up into 1,000,000 pieces, it would be 1,000,000 micrometers, and 10 to the -9 would be nanometers, and so on. We operate chemistry in a really small world. Atoms are going to be probably around 1 times 10 to the -10th and 1 times 10 to the -11th in meters. So really, really small things we're going to be dealing with. Let's go back the other way. If I have 10 meters, I have a decameter. 100 meters would be a hectometer. 1,000 meters would be a kilometer or kilometer. And we could go up and say 10 to the 6 meters would be a megameter, and so on. Let's look at some conversions for this and how to do this. So we did dimensional analysis. You have a strategy for solving things where you figure out where you're trying to go and you figure out your starting point, and then you solve a problem. And solving metric conversions works the same way. So we're trying to find how many meters are in a 10-kilometer run. Now, if you can do that in your head, that's fine, but we want to know some systems for doing it if the examples aren't quite so easy. So I'm going to do dimensional analysis method to show this. I start with what I know, 10 kilometers. I'm trying to find meters. I don't know what this is right here yet, but I know there's 1,000 meters in 1 kilometer. That's going to be my conversion factor that I'm going to use in step 3 right here. So the trick here is wherever you come from goes on the bottom. If kilometers is up here, it's going to be in the denominator down here. And then if kilometers is the denominator here, meters is going to be in the numerator. So it ends up being 1,000 meters per 1 kilometer, not the other way around. So if I take 10 times 1,000, I get 10,000 meters. Does that answer make sense? Well, meters are smaller than a kilometer, so I should have more of them. So this answer makes sense. Okay, there's another way of doing a decimal slide to figure this out using the chart, and let's show that method as well. And I think I'm going to just go to this chart, which is really the same thing. By the way, this is page 7 of the homework packet for Myers class, and this chart's on page 2 of Myers homework packet. Okay, so let's take a look at this 10 kilometers, and we're trying to go to meters. Kilometers is here, 10 to the 3rd, and meters is the base unit, 10 to the 0. So I'm moving from 0 to 3, or a factor of 3 places. I'm going up the chart. The measurements are getting bigger, so that means the numbers are getting smaller. And I'm going from kilometers to meters. Let's try that from 3 to 0. So my measurements are getting smaller, so my numbers are getting larger or bigger. So when that happens, I slide the decimal to the right. I put a decimal here and then move it 1, 2, 3 spots. So instead of being 10, now it becomes 10 with 3 zeros after it, or 10,000 meters. Let's look at another example. How many kilometers are in a 400-meter run? So if I have 400 meters here, I could do dimensional analysis. I'm starting at meters. I'm trying to go to kilometers. My conversion factor is 1 kilometer is 1,000 meters. What goes on bottom, what goes on top? Where I come from goes on the bottom, so the meters goes on bottom. Where I go to, what I don't know goes on top, so the kilometers go on top. and that's 400 divided by 1,000 gives me 0.4 kilometers. Doing the decimal slide, I could say I know my meters, which is here, but I'm trying to get to kilometers, so now I'm going from 0 to negative, or 0 to 3 in this direction, so I'm moving up the chart, and when I go up the chart, my numbers get smaller, so that means I slide to the left. So I put a decimal here after the 400, and I slide 1, 2, 3 places to the left, and I end up with 0.4 kilometers. Does that make sense? I'm going to a bigger unit, so I should have less of them. So 0.4 is much less than 400. A final example with that is a running race is 5 kilometers. How many centimeters is this? How many inches is this? So let's do the dimensional analysis way. I'm going from kilometers all the way actually to inches over here. I could do multiple conversion factors. I could do kilometers to meters, meters to centimeters, centimeters to inches. This is an English metric conversion. Wherever I come from goes on the bottom, wherever I go to goes on top. Then I come from meters, go to centimeters, or centimeters here, and now centimeters on the bottom here, inches on top here. I end up with 200,000 inches, or 2 times 10 to the 5th inches if I round that. What if I were doing the metric slide system? I'm starting with kilometers at 10 to the 3rd. I'm going to centimeters at 10 to the negative 2. So I'm going from 3 to negative 2, which is a movement of 1, 2, 3, 4, 5 places. So I'm going down the chart, so my numbers should get bigger. So I'm going to slide 5 places to the right. 1, 2, 3, 4, 5, and it becomes 500,000 centimeters. Now, to do the part to inches, it's an English metric conversion. I do have to do dimensional analysis for that. I put the 2.54 centimeters on the bottom, 1 inch on top, and then I finish it up with dimensional analysis, although I did a slide for that part right there. All right, finally, let's look at what's on page 8 of the homework packet, a couple more slide problems with the metric system that we're going to be using. So number 9 has a G and it has a big MG. So the G is really just for grams. Okay, there's no prefix in front of this one, so that's a 0. Notice it's a big M, not a small m, so it's not milli, it's mega. So I'm going from 0 to not 1, 2, 3, 4, but notice it goes from 3 to 6. So I'm going from 0 to 6. I'm moving 6 spots right here. And I'm going up the chart, so my numbers are going to get smaller. So I'm going to slide to the left. 0 to negative 6, 6 hops this time. 1, 2, 3, 4, 5, 6, and I get 0.86 megagrams. Let's look at this, and I have right here in number 13, I have mg and kg. The G must be for grams, the M is small m's for milli at 10 to the negative 3rd, and the K is for kilo at 10 to the 3rd. So notice I'm going from negative 3 to 3, that's going to be a movement of 6 places. I'm going again from bottom to top, so I'm going to, numbers are getting smaller, slide to the left, 6 hops this time, 1, 2, 3, 4, 5, 6. Notice that there is nothing there, so I put a 0 in there, I get 0.03. Check it out now, y'all. Let's look at this one. We have 0.235 grams, and we're trying to go to nanograms. And grams, again, is a base unit with nothing there. And now I'm going to nanograms, which is 10 to the negative 9th right here. This time I'm going down the chart, and because I'm going down the chart, the numbers should be getting bigger. We're going from 0 to 9, so we're going to slide to the right. 9 hops this time, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I end up with 235,000, or 235 million, or 2.35 times 10 to the 8th nanograms. Right, try these in your homework packet. For Myers Group, it's on page 7 and 8, and the metric guide sheet is on page 2. Check your keys for accuracy and ask if you have questions. Good luck.